start the crypt analysis of Vigenere Cipher. But before that, let me identify, or let me tell you few useful terms which we will going to use in the crypt analysis, right? So the very first thing is known as period. Period means length of the key. Okay. So for example, in previous example, the length of the key is 5. Okay. The key is bent. So we say the length of the key is 5. Okay. This is also known as period, right? Tabulo, we have seen that, there is a table which will helpful in encryption and decryption of Vigenere cipher. The top of the table have the key letters, I mean the whatever the letter present in the key, and the rows are corresponding to different English alphabet, and each cell actually represent what will be the value if we shift A with the first letter of the English with the first letter of the key, right? So this is what we have seen. So tabulo is the same table. Then there is an important property of Vigenere cipher, which is that it is polyalphabetic. Okay, if you remember, Caesar cipher is monoalphabetic. We use only one alphabet to do the encryption. Okay, so for example, in our example, we have used D. Okay, so we can use any alphabet, but we have to use a single alphabet to encrypt the entire text. Whereas if we call a Vigenere cipher polyalphabetic, it means it is having a collection of letters. Okay, so there are different letters that are present in the key. Okay, let's start attacking the Vigenere cipher. Okay, so basically, crypt analysis of Vigenere cipher involves three important steps. Okay, and all the steps are quite important. The very first step is establish the period. Okay, so if you remember, period means length of the key. Okay, so the length of the key we have to establish. First, we have to establish the length of the key. Let's call it n. In our example, the length of the key is 5. It may be possible, right? So when we try to decrypt the given ciphertext, we are not aware of the length. What is the length of the key? Okay, so the very first step is to establish the, or to identify what will be the key length that was used to encrypt this particular plain text. Okay, the plain text corresponding to this particular ciphertext. As a second step, what we will do is we will break the entire message into n parts. If you remember, n is the length of the key. Okay, so if I go back to our previous example, okay, so suppose we are having a plain text. Let's say assume a plain text attack is possible. Okay, this is the plain text. Suppose, let's say I'm using the same key bench. Okay, Bench, Bench, Bench. Okay. Okay, so this is the key, right? Suppose I get a ciphertext corresponding to this text. Now there is a peculiar property, if you can identify, why I would like to break the entire message into n parts. Because if you identify each nth part, okay, so the size of the key is 5, right? So if you identified each, or if you work with each fifth letter, there is a peculiar property that is associated with it. Okay, so let me just sorry, let me use a different color to identify, let's say, each fifth letter. Okay, so this is the first letter, this is the fifth letter, this is next fifth letter. Can you see some property of this? Yes, A, K, S, E. Is there any peculiar or particular thing which is associated with this? Me take another bucket of which says start with 2, okay, or the second position, and then again we will take every fifth position. So T, I, S, yeah, T, I, S. Yes. Can you see a particular thing about this? Somehow break the entire message into n parts, we will actually get each part which is encrypted with a same key. Okay, and if you remember, it is equivalent to Caesar cipher, right? So we have seen cryptanalysis of Caesar cipher using frequency analysis and things like that. So if we somehow identify this bucket, we know one very important property, that the elements corresponding to each bucket are encrypted using same letter. Okay, so we can apply cryptanalysis, which we learned in Caesar cipher. Okay, and then can identify the message. So this is how we will proceed in the cryptanalysis of our Vigenere cipher, right? And that is why I say that the first task is somehow to identify what will be the length of the key. If suppose we have established a particular length, then next job is to break the entire message into n parts, right? In this way, as I showed you in the example. And then third step is to solve each part separately, and you can apply frequency analysis and related things there to solve each part separately. Okay, and then we will combine the results. So now let's take an example that we would like to break this particular cipher. Okay, we only know two things. The first thing is that this is the cipher text, and the second thing we know is that the particular cipher text is generated through Vigenere cipher. Okay, we don't know the key, we don't know the plain text. Okay, and as a crypt analyst, our job is to somehow identify the key and the corresponding plain text. So let's see how we can do this. Now the first task is to establish the period or length of the key. How we can do that? So there is a principle given by Kasiski. Kasiski principle says that the repetition in the cipher text occur when the characters of the key appear over the same character in the plain text. Okay, so we have to identify these repetitions. For example, this is the plain text. The boy has the ball. This is the plain text, right? And suppose our key is VIG, 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 right? If you closely have a look at cipher text, you get some repetition in the cipher text. And the repetition is definitely because somehow we get the cipher text occur over the same plain text. Okay, so in this example, there is this THE, the, and VIG. This are encrypted. So this particular group, or maybe this particular group, is encrypted, and there is another such similar series of letters in the plain text which is again encrypted by the similar key letters, right? So we get this type of repetitions, and using these repetitions, identify the location of this repetition, we can get an idea of how what is the size of the, or what is the length of the key. Are you getting my point? So for example, you can see that, in this case, since the length of the key is 3, therefore we get exactly same repetition. Okay, now let me take another example. What if the, okay, suppose this is the length of the key. Okay, so can you see any repetitions in this case? Although I have not written the cipher text corresponding to this, but anyways, you can identify it, because, if we get plain text and same key letter, then definitely we will get same cipher text. So can you see any similarity in this? If we see this particular example, if the size of key is 5, okay, then this similarity changes. This occur if the key size is 3. Are you getting my point? So if key size is, or let me call it period is 3, then we get similar pattern in the ciphertext. If key size is 5, okay, or period is 5, we get some other pattern. If the keys the period is 6, we get some other pattern, so on so forth. Okay, so somehow this repetition tell us what is the period. It will give us some idea about the period. Our goal is to establish the period. Okay, we have to establish the period, right? Based on the repetitions occur in the cipher text, it will give us some knowledge about the period. Okay, so for example, if the key length is 3, there is this repetitions. Okay, this is the repetition. So if you observe this repetition very closely, you can find that there is a repetition after ninth word. Okay, so every ninth word repeat itself, something like that. Okay, you will get an idea that there is a repetition, some repetition. It is not like that only OPK will repeat itself. It may be possible that only a letter repetition will be there. Let's say K repeat itself. Okay, there is a repetition of K after few times, right? So it may be one letter word, it may be two letter word, it may be three letter words, but there will be some repetitions. Okay. So this repetition in the cipher text will give us an idea about what is the period. Okay, what is the length of the key. So for example, if we see the example which is given here, let's assume that this is our key. The period of the key is 3. Okay, we get these repetitions. Now, how can we identify the period is 3? So what we can identify that, the distance between two repetitions. So if you count these distance, the distance between two repetition is 9. There is a gap of 9 between two repetitions. It means that there is a high chance that the size of the key is either 1 or 3 or 9, whatever are the factors of 9. Okay, so there is a high possibility of that key size will be this. Okay, let's say suddenly I will change my key size, and the key size is now become, length of the key is now become 5. As soon as I will change the size of the length of the key, you can see the repetition pattern will change. Now it is not the same repetition. You got the idea? So this is Kaspersky principle. Let me explain you with some example. Okay. See, this is the standard frequency of English distribution. We have seen it quite a many times in tabular format. Okay, so this is a graphical format of that. Now, this is the shifted English frequency, right? Now, let's see what is the correlation between this. Suppose my plain text is, just to keep it simple, I am keeping my plain text as all A's. Okay, my plain text is all A's. Suppose my key is AC. Okay, this is the key. So I will do, since I am using Vigenere Cipher, I will repeat my key under this. Now, what is the cipher text which is generated using this plain text and this key? The cipher text is AC, 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 right? This is the cipher text. Okay. Now, what do the Kaspersky principle says? Suppose, okay, so one more concept I would like to introduce here, which is called coincidence. Coincidence. Coincidence means when the letter repeats itself. Okay, and I can see this repetition. Maybe so if I write like this, I will not shift my cipher text by 0 shift. If I write the cipher text like this, how many letters coincident with itself? How many coincidences are there? Almost all the words, not almost, actually all the words are coincident, right? So there is a high coincidence, right? What if I shift my cipher text with 1? Okay, so let me do shift by 1. So let me write it like this: AC, 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 sorry, AC, AC, so on and so forth. Now, how many coincidences are there? How many coincidences?
0.
Zero coincidences. Okay. Now let me shift it by 2. AC, 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 so on and so forth. Now, how many coincidences? You have to check coincidences with the cipher text. Okay. So let me just remove this for now. How many coincidences?
All.
All coincidences. Okay. Okay, fine. So let's, yeah, all are coincident, right? Now, if I shift it by 3, then how many coincidences? 0. If I shift it by 4, how many coincidences? Full coincidence, right? So can you see a pattern? Can you identify? So this is a quite a simple example, but can you see a pattern that depending upon the size of the key, the frequency of coincidences changes. So the coincidences that may occur will give you some idea about the length of the key. Are you getting my point? So here you can identify that the length of the key is either 2 or 4 or 6 or something like that. Okay, but it could not be 1, it could not be 3, it could not be 5. Why? Because we are getting 0 coincidences in that case. This is the cipher text. Okay, I don't know what is the key, even we don't know what is the plain text corresponding to this. Okay, now let's say, let's draw the coincidence curve. Okay, and let's see how it oscillates, then we can identify what will be the period of key. Okay, so let's do it together. So this is the cipher text. Let me shift it by 1. Okay, so if I shift it by 1, we get A Q R T U V Q S T V V X S L M P O. Okay, that's it. How many coincidences? So here I will write. You have to just count coincidences. Please count coincidences.
Ma'am, one.
One coincidence, where it is?
Ma'am, B.
V.
E matching with V.
Yes, V matching with V. Okay. So let's say 1, 2, 3, 4, 5, 6, let's say. And then we have 1, 2, 3, 4, 5. Okay. So when we shift by 1, we get this one coincidence, right? Okay. Now let me shift it by 2. Right now you have to count quickly how many coincidences are there. A Q R T U V Q S T V X. I hope I'm writing it correct. S L M P. Yeah. How many coincidences?
0.
Okay, 0. Fine. Let me shift it by 3. So 1, 2, 3. Okay. A Q R T U V Q S T V V X S L M. How many?
0.
Are you sure?
Yes, ma'am. 0.
Okay, 0. Okay. Let me do it for 4. So I think this is the 4, right? Yeah. A Q R T U V Q S T V V X S F. How many?
1.
1, where it is? This one?
Yes, ma'am.
Okay, we get 1. Fine. Let me shift it by 5. So 1, 2, 3, 4, and 5. Yeah. A Q R T U V Q S T V V X S. Yeah. How many coincidences?
3.
Ma'am,
1,
2. 2. 2.
2, 3,
Yes. Uh,
4. Anything
ma'am,
else?
4. Yes, ma'am.
4, right? So can you see a sudden hike in the coincidences? Can you see this? Can you observe this? But as soon as I shift it by 6, again you can see a lower frequency of coincidences. Okay, and if I keep on repeating this, maybe you can write it down in your copy and you can try for 6, 7, 8, 9. I am very sure that at 10 you will again get a hike. Okay, so right now we don't know what is the key, we don't know what is the plain text, but just by calculating the coincidences in the ciphertext, we can identify or we can somehow guess that this could be a possible period of the key. Okay, so you will observe that the period of this is 5. Okay, so at least we know that whatever is the key, it is of length 5. Okay, now is the size of the key. ठीक है, और मैं इसको कर देती हूँ ACB. लेट्स से दिस इज द की. ठीक है, ACB. ठीक है, कैन वी डू दैट?
Yes, ma'am.
ठीक है, तो अभी इसके करस्पॉन्डिंग साइफर टेक्स्ट कैसा आएगा? ACB यही आएगा,
Yes, ma'am.
है ना? तो अब भूल जाओ कि हमें की पता है. वी डोंट नो द की, वी हैव दिस साइफर टेक्स्ट. ठीक है, अगर अब अभी तो हमारा कैसा आ रहा था, कोइंसिडेंस कैसा आ रहा था? 1 पे हमारा हाई था, नहीं 0 पे, राइट? 0 पे हाई था, फिर 2 पे लो, 1 पे लो हो गया, फिर 2 पे हाई था, फिर 3 पे लो हो गया. अब हम देखते हैं हमारा कोइंसिडेंस कैसा आएगा. ठीक है, तो लेट्स शिफ्ट इट बाय 1. अभी ठीक है, अभी 0 पे है तो फुल है. ठीक है ना? 0 को हम काउंट नहीं करते. लेट्स स्टार्ट विथ 1, 5, 6. ठीक है, 1, 2, 3, 4, 5. अभी ठीक है, इतना ही मान लेते हैं. ठीक है, अगर हम 1 से शिफ्ट करेंगे, ACB. हाँ, कितना है कोइंसिडेंस?
Ma'am, 0.
ठीक है, 0. ओके, नाउ लेट्स शिफ्ट इट विथ 2.
Ma'am, 2 में भी 0 है.
2 में भी 0 आएगा.
Yes, ma'am. 3
पक्का?
में maximum.
3 में मैक्सिमम आएगा. फिर 4 में भी छोटा हो जाएगा, 5 में भी 0 हो जाएगा, 6 में भी मैक्सिमम हो जाएगा. ये 0 इसलिए आ रहा है क्योंकि हमारा प्लेन टेक्स्ट सेम है. ठीक है, अगर रियल लाइफ में आओगे तो तुम्हें हाइक्स मिलेंगे, पर यहाँ पे हो सकता है कुछ मिनिमम में कुछ मिल जाए. जैसे ये वाले केस में हमें 1 मिल रहा है कहीं पर, कहीं 0 मिल रहा है कहीं, लेकिन जो एक हाइक मिलेगा ना, वो एक इक्वल इंटरवल पे मिलेगा. ओके, एंड दैट विल हेल्प यू टू आइडेंटिफाई द लेंथ ऑफ द. तो जब भी हमारे पास क्या होगा कि जब अलाइनमेंट हमारा प्रॉपर होगा, ओके, यू विल गेट द मैक्सिमम वैल्यू. अब यू कैन कैलकुलेट इन टर्म्स ऑफ फ्रीक्वेंसीज, यू कैन कैलकुलेट इट इन टर्म्स ऑफ मैथमेटिक्स. ठीक है, तो वी कैन एक्चुअली कैलकुलेट इंडेक्स ऑफ कोइंसिडेंस फॉर ईच लेटर विच आर कमिंग इन द साइफर टेक्स्ट. Okay, but I am explaining you through the frequency because it is much easier to understand actually. Okay, so this is a live example. There is a plain text written here. There is the key of five different letters, and when you see actual coincidences, you will get graph something like this. Okay, so there is a period of 5 each. Okay, because the key size is 5. Right, so we will exploit this particular property. Okay, and this is known as Kaczynski or Kaczynski principle. Right, so we will use this to establish the length of the key. Now once the length of the key is established, what is our next job? We have to break the entire message into that many parts. So suppose if the period is key is 5, we have to break the entire message into 5 parts. And we know why we are breaking it into 5 parts, because then we will separate each fifth letter into different buckets, and then we will apply frequency analysis in each bucket. Right, so for example, if suppose the period is 3, we will make 3 buckets. So since because of the space complexity, I just put 3 here. So what we do, we will keep A, Q, L, M, X, A, S, P into one bucket, because they are, if the period is 3, then definitely all these are encrypted with same letter. Okay, same goes with R, L, O, S, K, P, Y, L, and same goes with S, P, G, Y, M, W, Q. Right, so we will break it in this manner. Okay, now what is our next step? What will be the next step? Now we have to run frequency analysis on each piece, right? On each piece we will do frequency analysis. So when we do frequency analysis, similarly I am representing it using graph. I already told you in the previous video that how to find the correlation between the plain text or the English text and the frequencies of cipher text, letters in the cipher text, you know, and you can somehow do cryptanalysis. But here we are just seeing at the frequency in the broader way. So if suppose these are the letter in one bucket, this is the frequency corresponding to the cryptographic letters, and this is the standard frequency, standard English frequency. We can see the graph looks quite same. Both the graph looks quite same. There is a shift of 2, right? So A most probably is C here. Okay, and hence we can guess that the letter corresponding to encrypt these, I mean, the letter corresponding to these cipher text is C. Okay, so this is how we cryptanalyze the Vigenere cipher. Okay, so now what is our first step? We will calculate the frequency. Okay, so if you remember, this is the same coincidence frequency that we would like to calculate. Okay, so if I click on calculate frequency, what this particular site is doing is they are dividing. So we have taken O, E, Q, O, something like that, right? So they have actually divided this into 3 letter words. Okay, so if you see the repetitions, it is same. So we have one letter which is Q. What is the letter? So yes, yeah. So what we identified is O, E, Q, O, O, G. Okay, whereas in this they have divided that O, E, Q, O, O, G into multiple parts. Okay, because they are repeating. So you can see that the spacing is 30. The spacing means the gap length that we have calculated is 30, and these are the factors of 30, right? Similarly, MOC is repeated, the gap length is 72, and these are the factors. Now, what are the possible keys? We can either select 2, either select 3, or we can select 6. So as I told you that it may be possible that you know, the people used the period of 6 because this is much more stronger. So in this side, what we need to do is now we need to select the period. Okay, so this is the period. Let's select it as 6. Okay. As soon as we select the period as 6, what is coming here? This is the frequency of English. This is the general English frequency that we have seen, right? So if you remember, A is a little bit higher and E is having the highest frequency, and T and all these things are higher frequencies, right? So this is the actual English frequency. And now they have given the 6 letters, L1, L2, L3, L4, and L5 and L6. Okay. Now we have to identify these 6 letters. So if I click on L1, what they did is they kept first letter, starting from the first letter, every 6th letter into one bin and find the frequency of that cipher text and plot it here. Are you getting my point? Yes? Yes, no?
Every 6th letter from the cipher text.
From the cipher text. Okay? So you can calculate it manually also. If possible, you can calculate it manually also. क्या होगा पहले वाले cipher text में क्या क्या आएंगे? Can anybody guess? एक का we can discuss for one and you can then identify the rest. पहला bucket. See, if we decide that the key size is 6. Okay, how many buckets we have to check? If we decide
6.
He is 6, right? So there are 6 buckets that we have to identify, right? So if we divide this particular text, the given cipher text, into 6 buckets, in the first bucket, first element is A. What is the second element? It is I, right?
Yes, ma'am.
then
Yes,
K,
ma'am.
then H, then O, then I, then A, so on and so forth. This is the first bucket. So what they did, they just took all these words which are coming starting from 1 to every sixth position, they kept in a bucket, and the second frequency graph is related to the frequency of letters present in that bucket. Okay. Now all the letters which are present in this particular bucket are actually encrypted with a single letter. Yes or no?
Yes, ma'am.
Right? So now what we have to do, we have to somehow do frequency analysis, the correlation, frequency correlation between the English frequency and the ciphertext frequency, right? So if you see, I think this is the actually, it is giving us the same frequency. See, A is okay, then E is, I mean, highest among all, then I frequency is also matching, O's frequency is also matching, T's frequency is also matching. Okay. So what I think that the first letter of the key should be A only. What do you think? Do you think this is the right position to stop? E and W is matching, right? Right. Now let's come to next letter. And this is how you can try, right? So you can identify each and every letter and then you can proceed. Okay. So let me now switch to, I will share the this particular thing. So let me take you to the slides again, right? So in that you can see a graph, histogram, right? And here you can see a simple writing. So A is little higher, then medium, 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 then E is here, so on. So okay, so let's start. So first matches characteristics of unshifted alphabet. So if you remember from our graph, A will remain A. Okay, it looks same. Then second, we are not able to identify that much. It looks something and something not. So what you can do is you can maybe just leave it as it is for that time, and maybe you can shift to the next match, right? So anyways, you have this sixth position. So if we have seen in the graph that the first position matches with the A, if you see the third position, it will exactly matches with I. Okay. So yeah, that you can identify from that curve. Do you want me to show that again, or you can check it offline?
We will check offline.
Yes, yes, thank you. And similarly, 6 will match with V. Okay, this is what written here, but you can check. And I have actually checked it. And yes, these three are actually, quite a similar curve, right? Once you get these letters, what you can do is you can substitute at least these letters, the plain text corresponding to these letters in the actual ciphertext, right? So this is what you got. Okay, so I have replaced all the six, starting from first, all the six location by shifting it A. Then each third letter will be shifted by I, and then each sixth letter will be shifted by B. Okay, and this is what we get. This is the ciphertext we get. Now, what we can identify from this? There is a very nice thing that you can identify, which is, if you see last line, you can say AGE, AJE. Okay, there is a very high probability. So you have to now find out the words, right? So one way is you can just try each thing for all possible combination. That is one way. Another way is you can just identify few words which are very much similar in frequencies, and rest you can identify by seeing the text. Okay, now in this, few letters are already decrypted, whereas few are still encrypted. So if you identify this AGE, there is a high chance that if you replace J by R, okay, then it will become ARER. Okay, so the 2 gram frequency, if you remember, 2 gram, 3 gram frequency can be used further. Okay, so if I go with this, what I have to do, I have to replace the second alphabet, right? Second is not done yet. So second alphabet I have to replace where A maps to S. Okay, I think we have identified the same thing, right? We have replaced this with S only. I don't remember now, but anyways, right? So yeah, so once I will do this, this is the updated text. This is the updated cipher text, okay, or a mixture of plain and cipher text. Again, you can have a closer look at this. You can identify that generally this CMMICAX is not a word. Generally, whenever you say economical, uh, tropical, something, so CAL will be the case, right? So you can do hit and try somewhat like that, and maybe you can come up with more letters. So 4 O will goes in place of A. So fourth letter will be O. Okay. And then once you are done with that, this is the final text you get if you replace the fourth alphabet by O, or you assume that the fourth alphabet key corresponding to each fourth alphabet is O. Okay. Now, if you closely look at this, you can identify few words. For example, this one, QI. If you have a Q in your text, always Q is followed by U. Okay, so you can use this information and can come up with something. So this says, U maps to I. Okay, so U maps to I. Accordingly, you can find out which is the word which is corresponding to this particular thing, and hence you can decrypt the message. Got the idea?